Welcome to Cosmic Discoveries, the definitive source for the most remarkable developments in space exploration and astronomy. In this segment, we will examine one of the most significant discoveries of our era, made possible by NASA's James Webb Space Telescope. The recent findings on Pluto, a dwarf planet that continues to defy expectations, are sure to astonish. For decades, Pluto has been the subject of intense interest among astronomers, and the latest findings will undoubtedly advance our comprehension of this icy world. The cosmos has always been shrouded in profound enigmas, yet the forthcoming disclosure will undoubtedly surpass the limits of our collective imagination. The NASA James Webb Space Telescope, JWST, has made a groundbreaking observation that could fundamentally alter our understanding of Pluto and its history. The data acquired by the telescope during its latest mission has prompted a profound sense of awe among the scientific community, as it suggests that Pluto may have been the site of a significant and catastrophic event. Let us proceed with a detailed analysis. The JWST's infrared capabilities enabled researchers to detect an unanticipated phenomenon: heat. In the case of Pluto, a dwarf planet situated at the periphery of our solar system, this discovery was both astonishing and perplexing. Given that Pluto has a surface temperature that plummets to hundreds of degrees below freezing, it is not surprising that the planet is considered frigid. However, the discovery of a considerable amount of heat radiating from its surface challenges this assumption. This finding suggests that Pluto was struck by an enormous object, potentially an asteroid or comet. The impact would have generated a substantial shock wave that reshaped Pluto's surface, leaving behind traces that the James Webb Telescope was able to detect with remarkable clarity. However, the disclosures do not end here. The surface of Pluto has long been a subject of scientific interest, particularly following the historic New Horizons flyby in 2015, which provided the first detailed close-up images of the distant world. The encounter was already groundbreaking, as it revealed that Pluto has mountains made of water ice, smooth plains, and active glaciers. However, with the advent of JWST and its advanced technology, we are now able to gain a new layer of understanding. Pluto is not merely a cold, distant rock. Rather, its surface is dynamic, evolving, and far more complex than previously assumed. The observations made by the James Webb Telescope are consistent with the hypothesis that a cataclysmic impact was responsible for reshaping Pluto's geological landscape. The available evidence indicates that the surface of the dwarf planet has been subjected to the influence of powerful forces, which may have resulted in tectonic movements or even resurfacing events that have exposed material from Pluto's deep interior. The detection of heat, when considered alongside observations of surface anomalies, suggests that Pluto's geological past may have been considerably more violent and dramatic than was previously assumed. It is now appropriate to take a moment to appreciate the technology that made this discovery possible. The James Webb Space Telescope, the most technologically sophisticated observatory ever launched into space, has transformed our capacity to explore the universe. The James Webb Space Telescope, JWST, was designed to surpass the Hubble Space Telescope in both scope and sensitivity. Its objective was to enable the observation of phenomena in space at greater distances and at earlier times than was previously possible. This would allow the formation of the first galaxies and stars to be seen, as well as providing insights into the formation of planets, both within and beyond our solar system. The infrared sensors of the James Webb Space Telescope, JWST, in particular the mid-infrared instrument, EMIRI, and the near-infrared spectrometer, NIRSpec, are powerful tools that permit scientists to study the atmospheres and surfaces of distant planetary bodies with remarkable precision. These instruments have initiated a new era of planetary science, offering insights into the formation and evolution of planets, moons, and other celestial bodies. To illustrate, one of JWST's most notable achievements to date has been the investigation of exoplanets, which are planets that orbit stars outside of our own solar system. A recent discovery concerns VHS 1256b, an exoplanet situated approximately 40 light-years from Earth. This massive planet, often designated a super-Jupiter, exhibits an atmospheric composition that is unprecedented. The instruments aboard the JWST have detected the presence of a swirling, chaotic dust storm on the exoplanet VHS 1256b. This phenomenon is notable for its unusual characteristics, deviating from the typical characteristics of a sandstorm. The storm is composed of silicates, which are tiny grains of rock, suspended in the planet's atmosphere. The discovery of such a violent, rock-filled storm provides an invaluable insight into the diversity of planetary atmospheres across the universe. However, this is not the limit of the discoveries that can be made. Furthermore, the James Webb Space Telescope is facilitating a more profound comprehension of the fundamental constituents of life. By analyzing the atmospheres of exoplanets, JWST is assisting scientists in determining whether these distant worlds could potentially support life. For example, the detection of sulfur dioxide in the atmosphere of WASP-39b, a gas giant situated 700 light-years away, represents a significant advancement in our understanding of planetary atmospheres. This molecule, formed by chemical reactions triggered by the planet's star, had not previously been detectable by scientists. The discovery of such molecules not only contributes to our understanding of the chemical processes occurring on other planets, but it also brings us one step closer to determining whether life might exist elsewhere in the universe. We will now return to the topic of Pluto. The recent discoveries made by JWST add new layers of intrigue to what was already one of the most fascinating planets in our solar system. The New Horizons mission placed a particular emphasis on Pluto's famous heart-shaped region, Sputnik Planitia, which continues to be a central focus in our understanding of the planet's geologic history. The heart-shaped plain, composed of nitrogen ice, may be the consequence of a significant impact that resulted in the formation of a deep basin, which subsequently became filled with nitrogen and other ices. However, recent data indicates that there may be additional factors at play. Some scientists now posit that Pluto's rotation was altered by this impact, causing the planet to gradually undergo a tipping motion as its internal structure underwent realignment with the newly redistributed mass. This phenomenon, known as true polar wander, has been observed in other planetary systems, including our own. In essence, this implies that a planet's entire outer shell can rotate in relation to its axis if a sufficient amount of mass is redistributed. In the case of Pluto, the accumulation of nitrogen ice in Sputnik Planitia may have been sufficient to cause the planet to reorient itself. This finding provides a novel perspective on the internal dynamics of dwarf planets like Pluto, shedding light on their potential for geologic activity and evolution over time. Adding to the enigma is the discovery by scientists utilizing data from New Horizons of immense methane ice formations on Pluto. These features, designated as penitentes, exhibit a morphology analogous to blades of ice, extending to heights of hundreds of meters into the atmosphere, a magnitude that surpasses that of any terrestrial observation. It is hypothesized that these formations are formed when methane in Pluto's atmosphere condenses and freezes at high altitudes, only to slowly evaporate during warmer periods, leaving behind these jagged structures. It is intriguing to note that recent observations indicate the possibility of these formations extending to Pluto's far side, a region that remains largely unexplored. Furthermore, it is important to acknowledge the discoveries made beyond Pluto. In 2019, the New Horizons spacecraft made a flyby of a small object in the Kuiper Belt, designated Arrokoth. This snowman-shaped body has provided invaluable insights into the early history of our solar system. Arrokoth is the most distant object ever studied by a spacecraft. Its ancient, untouched surface offers insight into the formation of planetary bodies. Current research suggests that Arrokoth formed from the slow, gradual merging of two smaller bodies, a process that occurred in the outer reaches of the solar system billions of years ago. Arrokoth's distinctive morphology and internal structure have contributed new insights into the mechanisms of planetary formation. The two lobes of Arrokoth are connected by a narrow neck, which suggests that the planetary building blocks in the early solar system collided at very low speeds, allowing them to stick together rather than shatter. This discovery challenges some of the previous theories about planet formation, providing new insights into the processes that created not only Arakoth, but also larger bodies like Pluto and even Earth. These findings exemplify the remarkable capabilities of both the New Horizons mission and the James Webb Space Telescope. As we persist in our exploration of the farthest reaches of our solar system and beyond, these missions are elucidating the intricate and dynamic nature of the universe in ways that were previously unanticipated. What, then, are the implications of these developments for the future of space exploration? It is evident that the James Webb Space Telescope is still in its infancy. The telescope's capacity to examine the universe in great depth, to analyze the atmospheres of distant planets, and to elucidate the mysteries of our own solar system is genuinely revolutionary. As the telescope continues its mission, further groundbreaking discoveries can be anticipated. Pluto, previously regarded as a frigid, inert world situated at the periphery of the solar system, has now been identified as a dynamic and active planet with a complex geological history. Moreover, it is not the only such discovery. Across the universe, from the frozen plains of Pluto to the swirling dust storms of distant exoplanets, the cosmos is full of surprises. We are currently experiencing a golden age of space exploration, where every new discovery brings us closer to answering some of the most fundamental questions that humanity has ever posed. How did the universe form? Are we alone in the cosmos? And what else is out there, waiting to be discovered? We would like to express our gratitude to all those who have joined us on this remarkable voyage of discovery through the cosmos. If you are as intrigued by these findings as we are, we encourage you to like, comment, and subscribe to our channel to receive updates on our latest videos. What are your thoughts on the recent discoveries regarding Pluto? Additionally, what other mysteries do you anticipate the James Webb Space Telescope will reveal in the future? We invite you to share your insights in the comments section. Until our next discussion, we encourage you to continue exploring the night sky. The universe is replete with wonders, and we are just beginning to comprehend its vastness.